All right. Sign on one, so we're going to get started. I would say welcome everyone to our Tech Talk series. Today we have John Orlando who's going to be speaking for us about his real-world usage of software-defined radio and his experience in the STEM world. If you don't know what the AI Futures program is, basically our whole mission goal is to connect with students or recent grads to help you find job opportunities within the Department of Defense. These are civilian job opportunities, as well as helping you connect with internships or scholarships if you're still a student but looking to expand that portfolio or need help with paying for school. We also will help with resumes, your digital presence, just interview practice, stuff like that. So if you're interested, please schedule a call with us. You can use that QR code. You can also reach out to us at contact@aifutures.us. And if you're looking for more information about the program, upcoming events, all of that kind of stuff, you can find us at aifutures.us as well. Speaking of events, we do events like this one. We host a virtual Tech Talk series, but we also do in-person events like our AI ground vehicle challenges, and we sponsor events. Speaking of, we are sponsoring the upcoming Sparta Hack this weekend. Our own team member, Mark Jenny, is going to be speaking. He is an expert in all things STEM and AI and ML, so he is wonderful to hear speak. So if you're going to be there, please, we encourage you to come and hear him speak. And yeah, as Joanna is reminding people, we have chat turned off, but if you have questions at any time during this presentation, please submit them to the Q&A, and we will be doing Q&A at the end of this talk. And so with that, I'm going to stop sharing my screen. John, I'll allow you to take over. Thank you, everyone, for being here.
Awesome. Yeah, thanks, Molly. Let me pull up the deck that we'll be talking through today. So I'll go into slideshow mode and make sure you guys see that coming through okay? Looks good? All right.
Yep, looks good.
And I'll also go through, and let me do a quick slide, just go down a slide. Does the slide change for you? I had an issue yesterday where the slides weren't changing, so.
It is changing.
Right,
yeah,
perfect.
You're good to go.
Super, awesome. Yeah, much appreciated, Molly, and the rest of the AI Futures team for giving me a chance to come and chat. As she said, my name is John Orlando. I'm the co-founder and CEO at an engineering company called Epic Solutions based out of the Chicago suburbs. The talk today is going to be about an area on the technology side that's near and dear to my heart, software-defined radio, which if you don't know what that is, don't worry, we'll spend some time going through that. But more importantly, real-world usages of software-defined radio. If you have any background in this space, it's something that it's been around for a while, and a lot of people go like, how do you actually use that for benefit? And we'll talk through a bunch of different use cases that kind of provide some perspective for where it's used today and the value that it brings to our customers. And it turns out you can build an entire business around that we've done at Epic Solutions over the last 14 years. So we'll talk a little bit about Epic, give you guys some background on that for awareness. Like I said, we'll talk about what it means and what it takes to build a small business and bootstrap a small business that's centered on this SDR topic. We'll get into those use cases, and then we'll wrap up and do some Q&A. I tend to talk a lot, so I'll try to watch the time and make sure we don't go off on too many tangents here. So a little bit about me, help set the table. I knew I was going to be an engineer when I was 6 years old. I've been a maker at heart my entire life. I graduated with my Bachelor's of Science in Electrical Engineering back in 1998 from the Rose-Hulman Institute of Technology in Indiana, and I got my master's a little bit later in computer science. Spent 11 years at Motorola outside of Chicago here in Schaumburg, Illinois, working in this very area that Epic focuses on today. I was doing work in software-defined radio, applied to a whole range of problems related to communications and defense applications. And so I was there from 1998 to 2009. And eventually we got to the point where we said, like, how hard could it be to start a business and do a lot of these same things myself? Oh, I think did I lose the screen sharing there, Molly?
You did, yeah.
Oh, let me, that was weird. Let me pop that back up. All right, are we back?
Yes, we're back.
Good. All right, cool. So started Epic back in 2009 after a career at Motorola, first 11 plus years. Eventually got to the point where we said, like, well, we think we can do this software-defined radio thing ourselves on our own dime. How hard could it be to start a business and make a go of it? So we bootstrapped ourselves. The last 14 years have been kind of a slow and steady growth of our business and lots of interesting technical problems to solve related to a range of defense applications where software-defined radio is critical. And we'll get into some of those in a moment. But outside the technical world, I'm married, a couple kids. I play soccer and piano and screw around with robotics and welding and like to go backpacking. Lots of things that kind of keep you busy outside the technology time. So a balanced life is the goal here, as always. So a little bit of background about Epic and who we are as a company. I mentioned previously, we've been in this software-defined radio game for the last 14 years, focused on building flexible RF Lego bricks, essentially, that can be used to answer the mail on a range of different defense and intelligence-related problems that are out there. And we'll get into some of those a little bit later. But to date, to give you some kind of size and scale of our business, we've got more than 400 customers worldwide and have delivered north of 20,000 software-defined radios since 2014 to a pretty broad range of use cases. Some things that I would have never guessed a long time ago would possibly need to have a software-defined radio. We've got 110 total team members based both in Chicago here as well as an office up in Montreal that we acquired earlier about a year ago in 2023. So the team here outside of Chicago in Rolling Meadows, Illinois, this is predominantly engineering as well as our production. We've got sales team, customer-facing sales team all over the U.S., so Florida and New Hampshire and California and Texas and Maryland, Virginia area. So kind of people spread out to be able to support the wide range of customers that we engage with. And over the last 14 years, we've really focused on these defense applications, some of which we'll talk about today, but really trying to be there to help accelerate the development of solutions for a wide range of problems that seems to constantly be changing in the wireless landscape around us. So lots of interesting problems, lots of interesting places where software-defined radio can be used. Our core business in a nutshell is really focused in 4 main areas. I add the 4th with space kind of added into the top. We'll talk about that in a second. But the bottom 3 is really how we think about most of our customer engagement and how we provide value to our customers today. So on the left side, building sort of the Lego brick software-defined radio modules and delivering them to other customers that are able to use them and build some sort of product, some sort of hardware product around them to solve a need in the defense space. So that might be a communication system, that might be a survey solution to understand is someone trying to jam a radio signal of interest. That might be a drone detection system where they say, hey, there are drones flying around nearby and drones have lots of radio signals. And people, if you watch the news, there's cases where drones are being detected at airports where they can cause all kinds of havoc, or people are strapping, if you follow the Ukraine news, people are strapping bombs to drones and using them to even wreak more havoc. So this wide range of areas where being able to understand what's going on in the RF world around you and then take action is pretty important for a number of applications and use cases these days. So that's kind of on the left side. On the right side, we also use those same SDR modules that we develop that we'll be talking about in a few minutes here, and we build some turnkey solutions internal to Epic. So cases where we can take these modules and we can build not just the hardware, but put software applications on top of them, put the whole thing in a box, put a user interface on it, and then have that be a final product that we sell to our customers, just the same as the way we enable certain customers to tackle problems. And then in the middle there, we do some engineering for hire work. That's a pretty small sliver of our business. 80% of our revenue is coming from just selling products these days, whether that's the radio Lego bricks that we'll be talking about or the complete turnkey RF sensing solutions. Space comes into the mix. I mentioned we have an office up in Montreal. We acquired a small company called Zyphos up there earlier about a year ago in January of 2023. They focus on making little computer boards and processing sensor cards that go into satellites, small satellites, CubeSats, nanosats, things that get launched into outer space. So they're, while most of the work that Core Epic does is terrestrially in land or air, or water for maritime applications, the team up in Montreal covers down on the space side of things. Okay, so our strategy as a company, I mentioned we build these Lego bricks, these software-defined radio Lego bricks that are effectively flexible radio tuners, radio transmitters, and receivers that can tune to a wide range of RF frequencies, and then be able to digitize and provide a means to process the digitized radio spectrum with a computer. So that could be a small little embedded computer like a Raspberry Pi. That could be a laptop. That could be a giant server that has lots of processing power. So we have a family of these Lego bricks, and those Lego bricks get used by both our team as well as our customers to come up with these complete solutions for understanding and interacting the RF world around them. So lots of different things you can do with it, but that kind of sets the core basis for what we do. If you're not familiar with what software-defined radio is, this gives you a super high-level view of the main building blocks of how to think about software-defined radio. Traditionally, hardware radios, like the standard hardware radios that have been around for decades, they are fixed purpose. They tune to one set of radio frequencies. They do exactly one thing. If you have an FM radio in your car, the only thing it knows how to do is receive FM radio stations. Or if you have a GPS receiver, a standalone GPS receiver, the only thing it knows how to do is receive GPS signals from satellites in outer space. The idea with software-defined radio is to add flexibility to every part of the hardware and software chain such that the personality of an SDR can be changed just by adjusting the software. So in other words, what that means is you can have a single platform that can be capable of serving as a GPS receiver in one instant, and then changing the personality, the software on it, change its personality, and then have it be an FM receiver in the next instant. Change the software again, maybe it turns into a 4G base station for supporting interfacing with cellular phones. Change the software again, maybe it becomes your access point, your Wi-Fi router at home. So this core idea of being able to have more flexibility has been around forever, but technology's taken a while to kind of get to the point where it's really practical and realizable, because it takes a lot of pretty clever engineering to get there, both on the hardware side as well as the software side. And some of the pieces still aren't solved. Software-defined antennas are not really a thing yet. People are working on it, but most of the other parts of the chain behind the antenna, the RF front end, the mixers and synthesizers and data converters, and then of course the back end where you would be running software. Most of those pieces provide capability that let you reconfigure on the fly to be able to interact with a range of different wireless signals. And if you are doing AI or ML, and since this is AI Futures, the place where you would typically be running any kind of neural net or any kind of machine learning processing engine, it's on the very back end of the system on that host compute, which again, could be a Raspberry Pi, could be a laptop, could be a higher end compute platform like a server. So the idea here is you get these software-defined radios in place, you build these little platforms that could be anything from small and handheld to something that could fit in a backpack to even larger, and you put software on them. You put software on them that is able to then implement a range of different wireless protocols, Wi-Fi, Bluetooth, 5G, you name it. And the more personalities you can put onto the platform, the more capabilities it provides to end customers, and the more problem sets that it can potentially be applied to. And it's not just commercial waveforms. You can also have non-standard waveforms developed that would be of value, and we'll talk a little bit about that a little bit later. But it doesn't always have to be just the things you think about in terms of the standard commercial radio waveforms out there. I mentioned drone detection as a problem that's pretty important and gets a lot of attention these days. Some of the drones use very bespoke, customized radio signals to transmit video feeds back to the person controlling the drone. None of those standards may not necessarily be published, but if you're trying to build a radio system to detect the radio transmissions coming from a drone, you need to be able to also detect those customized signals that are getting sent from the drone to transport the video signal. So it's a pretty broad range of places where you can apply these kinds of modules. So and the size, weight, and power of these modules ends up making a big difference. So SWaP and performance kind of being the two areas where you kind of think about you can make trades. So if size, weight, and performance are important to you, we as a company, we've developed part of a portfolio. So these cards, these software-defined radio cards, as shown on the left, are quite small, right? That's a dime sitting next to them. So you're talking about something that's a couple of square inches, all the way up to on the right side, which is the size of a small paperback book, and everything in between. So some customers want to buy different form factors for different problem sets. Really depends on what problem they're going after, what they're trying, what kind of end solution they're trying to conceive of and develop, and how much of the problem they're looking to take on themselves. So we sell little cards, the little circuit boards that have electronics on them and have software that we've developed on them. Some customers buy those. Other customers want a fully housed solution. They don't want to buy a circuit board. They want to buy something they can just write software on and deploy it. So pretty wide range of possibilities here. And I won't bore you with the details, but when people think about a software stack and or a system stack of what it looks like, from hardware to FPGA to field programmable gate arrays to kernel space software, all the way up to user space software, there's lots of different pieces that are kind of in the mix here. You've got your radio hardware itself, everything from antennas and tuners and mixers and data converters in the bottom. Eventually, most SDRs end up getting digitized radio spectrum into a field programmable gate array that does a bunch of local digital processing on the signal. That would then transport it up to the next layer in the hardware stack, which is usually the computer of some sort. Again, Raspberry Pi, laptop, or server, or anything in between. There is kernel space software, low-level software that's running at the bottom of the operating system, helping to interact with the hardware, as well as higher-level software that's providing whatever application is necessary that you're trying to solve. So this is where you could be running a 4G base station, or you could be running a drone detection application, or you could be running a custom communication system that's using all of the hardware and software below it to achieve the desired effect. So when I first started learning about software-defined radio, I always assumed the holy grail at the end of the day was really to be able to put as much functionality into something that you could hold in your hand and hold up to your face to make calls and interact with all these different radio signals, effectively a Swiss Army knife that could be in your hand. What I learned was I was completely wrong, and that is not really where the holy grail lays for software-defined radio. It turns out that consumers in particular are very fond of their cell phones and the battery life that comes with them and the price point that they're at. And the only way to really achieve the mix that we have achieved in the industry today is to do it such that there is not the inherent flexibility that software-defined radio provides. So while it's true, the thing you hold in your hand to make calls from also has Wi-Fi and also has GPS and also has Bluetooth, it's not actually a software-defined radio. They put individual hardware chips down for every one of those functions and have specific software that is tailored for every one of those waveforms to kind of meet the price point requirements, as well as to meet the power consumption requirements. So software-defined radio, if it was really to have a handheld software-defined radio you could put in your hand, the only thing that you would be changing would be the software that would run, and it would be a common set of hardware that would be running all of the applications. So if it's not a holy grail, is not something in your hand that you would hold up to your face and use to talk or surf the internet, like, what is the value of SDR? Where does it come into these days? So that's what I want to spend some time talking about that. And what we found is the benefit for our customers is, as I mentioned before, is we're helping them accelerate their RF product development, cases where they want to transmit and receive RF signals that may be over a very wide range of RF frequencies. They may have multiple channels of receive and transmit that they want to handle simultaneously. And they want to be able to use all that in a well-defined API, something that gives them the ability to have as much control and as much flexibility of the system as they possibly could. And if you can mix all those things together, you can have strong success on the back end and have customers that are actually using the systems for a range of different use cases. So let's connect the dots and let's talk about 4 or 5 use cases that are common today for software-defined radio. So the first one I'll walk you guys through is a use case that we've been working in for a number of years. There is a problem set that our customers have where they have secure work areas within the government. And those secure work areas are usually have big, thick metal doors that you have to go through to get into them, and they don't allow you to bring cell phone or Wi-Fi or Bluetooth into those secure areas because they don't want to have security leaks. So usually what you would do is you would take your cell phone and you'd put it in a little locker right in front of the secure area, or you would take off your Apple Watch and put it in the locker, and then you'd go in. The idea here is they want to minimize the ways in which information could potentially leak out from within inside that secure area. And so one use for software-defined radios is to actually have to support a sensor platform that can be installed inside these secure areas that monitors and looks for wireless signals that aren't supposed to be there. So one of the products that we make as a company is called Flying Fox. It's a sensor about the size of a cigar box. It gets installed inside of these secure work areas. It's got 4 of our SDRs plus a single board computer that runs a bunch of software that we've developed for 24 hours a day, 7 days a week, 365 days a year, looking for cellular radio signals, Wi-Fi radio signals, and Bluetooth radio signals. And if we see them, we send an alert to a security guard. They actually have, there's a little user interface that comes along with it, so we can put a dot on a map and say, hey, there's a Verizon phone in the back corner of secure conference room 3. You may want to send a security guard out there to go and see what happened. Usually it's just someone who forgot and left their phone in their pocket. Sometimes it's someone who's doing something they shouldn't be doing. So the more that we can help our customers on the security side with this, the better off they are, the better that they can ensure that the secure information they have in their facilities can be kept secure. Another use case on the safety side, not so much on the defense side, we had a customer come to us and said, that was in the railway industry, and they said, we have this problem where the team members who are responsible for driving the locomotives on the trains will often get on the rails and get underway on some long cross-country route, and they'll be in the middle of nowhere and they'll be bored. And so what do? They fire up their cell phone and they start looking at YouTube or Facebook or TikTok or whatever the case may be. And the issue that the railway companies run into is there are accidents that happen every single year where trains are crashing because of a distracted driver effectively. So they came to us and said, is it possible for you to have a small little platform, develop a small little platform that could go inside of the locomotives and let us know if there are any cell phone transmissions that are happening at any given time? They have mandates, company mandates that say no cell phones are allowed to be operated inside of the cab of the locomotive where it's being driven. You're supposed to put it in airplane mode, but humans do things all the time that they shouldn't be doing. So this was one of these cases where we were able to take one of our SDRs, develop some software that runs on top of it and put it all in a little housing that is the black metal looking thing at the bottom there. And then these sensors get installed inside of the cab of the locomotive for the train. And we sit there just looking for cell phone transmissions if they're happening anywhere inside the cab of the train or the cab of the locomotive. And if they are, we can then trigger a signal that says, hey, a cell phone is being used inside the cab. Take whatever action you feel that you need to take. The railway company actually turns on a video camera and gets some video footage of the individual when we signal this. Their main goal is to be able to know definitively, are they really using their phone, reprimand the person to say like, hey, you're not supposed to do that. And then ultimately have a safer posture in terms of potential accidents that could be happening due to distracted train driving. So not something I would have ever thought about when we started the business 14 years ago, but an active use case today. We've got about 3,000 of these installed on trains in the US here locally, doing their thing each and every day. Third use case we talked about before, detecting and mitigating drones, right? This is drones have been popular for the last 10 years or so and have really gained a lot of traction as the pricing has come down. Many people buy them at Best Buy or Target and fly them around their backyard for fun. They are a ton of fun to play with. The challenge comes when you think about the level of access a drone can potentially have from a faraway distance, from 100 feet away, from 1,000 feet away. You can fly a drone to an area and take some effect on that area without ever being nearby. So in the news these days, I mentioned the Ukraine situation. There certainly are news stories showing people that are using drones with explosives in different manners. Similarly, airports and sports stadiums have a very big concern for drones that would be coming into a facility where you've got lots of people or lots of expensive planes, and bad things could potentially happen if a drone got flown into the engine of a jet as it was taking off. Or even worse, if it had explosives and it landed in the center of Wrigley Field, like what kind of damage could it provide? What kind of damage would occur there? So software-defined radio gets used to be able to build the systems to detect when a drone is nearby. The way it does this is, I mentioned before, drones emit lots of different RF signals, whether it's the video feed from the camera on the bottom of the drone or some other signature indicating some information that's being sensed by the drone and sent back to the operator. So people build systems. Companies have developed these systems for detecting those radio signatures, and in some cases, not just being able to detect and identify them, but also to be able to actually take control of the drone itself and tell it that it either needs to go home or it needs to land immediately. So customers have reverse engineered the protocols that some of the drone providers use for commanding and controlling these drones. And yeah, they're able to effectively make sure that the drone is not wreaking whatever havoc it could be wreaking. So many of our customers today in this space are using our SDRs as the core building block that supports this sort of capability. And it's a problem set that only seems to be getting worse. It's a really interesting one because of the strange asymmetry for going and buying a drone for $100 and strapping some explosives onto it and then flying it and instilling quite a bit of potential havoc. It's not something that really people have had to deal with. The defense industry has had to deal with in the past, but like that particular universe is getting a lot of attention, a lot of funding, and a lot of smart people trying to solve problems around how to make sure the problem doesn't get worse going into the future. The fourth example I'll talk about, CubeSat Communications. We mentioned before that we have a team up in Montreal now that focuses on building computer platforms and sensing platforms that go into space. Prior to that, though, about 5 years ago, we had a customer of ours approached us and said, hey, we've seen your little software-defined radio modules. We think they'd be perfect for going inside of CubeSat, a small sat, as a communication link that we would fly around in space and use to transmit information from space down to a ground station. We said, hey, we've never done any space qualification or space testing for SDRs. This is a bad idea. You probably shouldn't do that. Customer said, don't worry about it. We'll take all the risk and do all the testing and validating ourselves. We said, as long as you're willing to sign off on that, that is perfectly fine. Company then spent about a year doing development and testing and validating that the radio cards would survive the outer space environment that they had intended to launch them into. And if you're not familiar with outer space, the challenges that come with that, there's weird radiation that you get exposed to in outer space that we're protected from here terrestrially on Earth. And once you're in different orbits, the radiation limits are different, and that radiation impact can then cause electronics to reset. It can cause digital ones to turn into digital zeros in a memory device, and all kinds of strange havoc can be wreaked. So we said, hey, as long as you're comfortable with the risks, Mr. Customer, by all means, go ahead and take a shot at it. And so they went through and developed a fully flexible bidirectional data communications link where size, weight, and power was really critical. They were putting it in a very small satellite. They did not have a lot of room to spare. And so the fact that we had a card that was just a couple of square inches and weighed less than 10 grams was really attractive to them. They developed not only the full communication protocol, they developed some of the mitigation steps they needed to be able to take to be able to support the radiation environment, because Like I said, our hardware was not designed from day one to be able to support that. And then probably the best email I got in all of 2018 when they started to, when they were working with this, was the day they said, hey, we launched into space and we just closed the communications link from the radio, your radio card down to our ground station from orbit. And so like we were ecstatic to hear that that worked. Today they've got about 40 satellites flying around in low Earth orbit with our SDRs on them providing the communication link. So really interesting use case. And again, one of these things where the flexibility to be able to operate at different frequencies and be very small form factor was critical to be able to support their particular use case. The last one I'll talk about here, how are we doing on time? All right, I think we're going to be good. The last one I'll talk about here is probably a little bit more familiar to folks. I suspect most of the people in the audience have a cell phone in their pocket that communicates with, they use for making calls or sending text messages or surfing the web. Those cell phones use radio signals to communicate with a Wi-Fi router locally or a cell phone tower that may not be so local to you. So sending radio signals back and forth for facilitating that communication is a pretty standard thing that happens millions of times per year. However, not every application for cellular technology is going to use standard radio frequencies. We had a customer come to us and said, we have some RF spectrum that's licensed that we would like to be able to use for a 4G LTE cellular communication system, but nobody makes the chipsets or nobody makes a cell phone that actually operates at those radio frequencies. If you think about Qualcomm and Apple, the people that make the chipsets that go into most common cell phones today, they go where the money is, and where the money is where the mass market deployments are, where they can sell, hundreds of millions of units per year. This particular customer, they didn't want to use the standard frequencies. They had a chunk of spectrum that was licensed to them that only they would use, and thus there was no waiting market of cell phone makers or base station makers that supported those frequencies. They said, what we think we want to do is we want to be able to use your software-defined radio and put all of the protocol processing and all the other application processing necessary on top of that to support this sort of unique frequency of operation. And sure enough, we spent some time talking through with them about how to approach the problem. We provided some consulting expertise related to how cellular signals, how to kind of use our radios for a cellular processing solution, both for the phone, the user equipment side, as well, the mobile side, as well as the base station. And since then, this customer has deployed complete systems that have our SDRs in use, both as the terminal, the kind of the mobile device, as well as the base station side. So very successful project for them. This was a defense customer that wanted to deploy LTE in a unique frequency range. And interesting with them, it's kind of a defense entity from one of the larger well-known cellular providers, but they just didn't have the access or the ability to be able to deploy a system at a non-standard frequency without spending just an insane amount of money to go get custom ASICs developed and kind of build out something from scratch. So SDR proved to be a really good fit to support the use case here, and the reduction in size, weight, and power was pretty critical to be able to support what they needed. Going forward, they're looking at being able to upgrade to 5G. In that case, it literally is just changing the software on the system. There's no need to adjust the hardware on either side, as long as you have enough processing cycles to be able to support some of the improvements that came through with 5G compared to 4G. So if 14 years ago you had asked me what people would be using software-defined radio for, a decade later, I would have gotten most of it wrong. I really didn't have a great sense of where the needs and the gaps were at the time. We just knew that if you built the right Lego bricks and you put a good API around them and you provided kind of white glove customer support, that you should be able to reduce friction and really accelerate development across a range of different problem sets. And thankfully, as we've learned over the last 14 years, that has mostly rung true. We've really seen quite a bit of adoption across a number of different customers where they're able to go from a concept of some kind of product or some kind of solving some sort of problem that they'd like to develop and get it into prototype stage and then get it into production much more quickly than they could if they had to develop everything by themselves. So being able to come to a company like Epic, look through our portfolio of radio modules, say, great, that one fits the bill for what I need in terms of size and weight and power and flexibility, and then get that designed in. It lets them focus on whatever their higher level application and problem set that they're going after. And that gets more solutions into the market more quickly, and it gets problem solved for customers more effectively, and hopefully improves the safety and security of everyone around us as we go forward. So just to kind of wrap up here before we do some Q&A, software-defined radios really are foundational elements in dozens of different use cases these days. And the number of use cases that they're supporting is growing with every passing quarter. More and more problem sets are being, more and more challenges are showing up on the RF landscape where an SDR can be a viable component of a solution. The folks that have been making fixed function hardware radios of yesteryear, they're really sort of starting to trend down, especially when it comes to these defense applications where the flexibility ends up being important. When you think about protecting warfighters and people that are on the front line ensuring our safety and defense and security, they want to be able to have something that can adapt to whatever threats they're going to be able to see as they change in the coming years. And so having SDR ends up being a real critical piece of that equation. And it's not just defense applications. I mean, we have customers in the test and measurement space where if you're building RF test equipment, if you open them up, it really does start to look like a software-defined radio at the end of the day, all the way up to and including other kinds of communication systems like we talked about. As a company, I'll say we got some coin flips that went our way as far as figuring out the right combination of features and capabilities for our radios that would actually be able to check the boxes for this wide range of use cases. If you're ever thinking about starting your own business and understanding the technology side and the engineering pieces of being able to build a product, that's certainly important, but also having enough clarity and enough understanding of the market problem sets and the market segments and where there are gaps to try to get everything dialed in and not just make cool technology. It really does take both of those pieces. When we started the business 14 years ago, I would have told you engineering is the hard part. Like, engineering is hard, but there are lots of other hard parts that are equally as challenging with growing a business as well as engaging with customers and ensuring products can be successful. And last but not least, there really has, if any of this is interesting to you, there really has never been a better time to kind of dive in feet first, whether it's software or hardware design or RF engineering or antennas. It is a rich field with lots of interesting challenges. I said the last 10 years or so, a lot of the technology has fallen into place to be able to enable these sorts of things. There are plenty of problem sets that still exist in this world because people always want things smaller. They always want more simultaneous functionality, or they want to be able to ensure that that they can put it in their pocket and have as few people see that it's actually a thing doing whatever it is it's doing as possible, because they want to keep a relatively low visibility cover. So lots of interesting problems to be able to dig into. I highly encourage, whether you're hardware or software or mechanical or electrical or whatever the case may be, if you have a technology slant, spend some time looking into software-defined radio a bit more. And I'd be happy to, if you have any questions, shoot me an email. Always interested in being able to help support and promote the next legion of engineers that are going to be coming through. And with that, I am wrapped. And I think we've got a little bit of time left for questions here, Molly.
Yep. So we'll go ahead and get started with questions. I know we were getting a lot.
Yes, I saw them coming in. How do you want to handle these? Do you want me to
I'll approve them. I'll answer some AI Futures ones first. So There was a question of where we can find the recording. So this will be reposted to YouTube, our AI Futures YouTube. After it takes us about a week to get a turnaround. So yeah, within the week, that'll be posted there so people can watch it back at their leisure. And let's see. Oh, somebody asked, would obtaining the CompTIA Section Plus be a good step to prepare for a role like this? That's a great question.
Yeah, I mean, CompTIA, I'd say usually that CompTIA is something that would be more focused on software only roles, and kind of plays into some of the security pieces that play into that. So I would say when I think about our team today, software is our largest team. We've got, I don't know, 25 or 30 kind of full-time software folks. We don't have a ton of folks that have that particular certification. Most of the software folks that we have on our team, they kind of run the gamut from their Linux kernel device driver folks to Linux application developer folks to people that are building HTML5 or React-based user interfaces that run in a web browser. So that's usually the kind of software folks that we would be looking at Epic. But that being said, I mean, it's a pretty wide range. There's lots of places where different skill sets can be applied here.
All right. Next question is, what do you typically look for in an applicant?
We look for people that have demonstrated making capability as certainly one of the important elements. And so that could be senior projects or projects in college. That could be home projects. I mean, honestly, people that have home projects outside of their schooling are often more interesting to be able to talk through because it just shows they have a passion for what they do and they do it in their own time. We place a lot of emphasis on humility, respect, and trust as important non-technical attributes. Like humbleness and humility, as far as I'm concerned, are way too undervalued in today's market. And if you can combine good, solid technical chops with a humble perspective, you can unlock some magic. So certainly those pieces end up being important when we think about them.
All right. Has there been any failures in the field, such as any drone detection mitigation failures or any SDR failure? Would any failure be based purely on the software?
Yeah, there's lots of, like any advanced technology system, there's lots of things that could go wrong. We have an exceptionally low return rate for our product compared to what we see as industry standard. In terms of will systems fail ever, like certainly is possible. Like we provide warranties for our hardware. I know we've got customers that have had systems fielded for 6+ years to date, and they're continuing to chug along. The ones that are in space have been in orbit now for 5+ years. At least the first one has been in orbit for 5+ years. So yeah, I mean, I would say it's always possible. Not necessarily just the software can go wrong. There are still things in the hardware that can go wrong. We had one customer, they literally ran over one of our radios with a Jeep and they sent it back. They said, "Oh, it doesn't work anymore." And we're like, "You think it doesn't work anymore? Like you ran it over with a Jeep. Like what did you expect was going to happen?" So yeah, it varies quite a bit.
Sure. Right, next is, I'm a freshman university student majoring in computer science with a focus in cybersecurity. Does your company offer any internships, preferably remote, for students like me?
We do offer internships. Usually we are getting our interns locked down in the September, October timeframe for the following summer. So we've got 2 interns that are joining our team for summer of 2024. But if people are interested in summer 2025, by all means, at some point between now and next September, shoot me an email and we can make sure that you're in the mix for things. We do recruiting at a few local universities. So Purdue, Notre Dame, University of Iowa are some of the ones local here out in the Chicagoland region that we hit up.
And we also, AI Futures, can help link you up with internships as well. So we can help find you things that fit, maybe that are closer to home for you. So definitely, I would say book some time with us because that's something we can definitely help you with as well. So what are some challenges you encountered when you first founded the company?
Well, since we bootstrapped ourselves, we didn't have a paycheck for the first bit of time. When we had agreed at the time that we would make a run of it for 9 months. So we said if we can't make money show up in 9 months, then we should probably do something else. And we had myself and the other 2 co-founders had saved for about a year prior to starting the business to make sure that we had enough runway. My wife was staying at home at the time with our 3-year-old and our 3-month-old. So we were it was some there were some tense moments in the first several months, but on month 7 we had landed our first contract that actually started paying us, and so we were able to start bringing in dollars there, and then it's been kind of growing ever since. I'll say the other thing that's always challenging is in complementing the challenges you have on the technology side. Growing a team and each stage of growth of a team is tricky, and it's hard. Like, people are hard. They're these massive, like, nonlinear systems that you just cannot always understand how they're going to be thinking, and yeah, the people side ends up being pretty tricky. So now at 110 people, each stage has had its challenges. Having a team of 3 was different than a team of 10, was different than a team of 25 or a team of 50, and so on. So that part's pretty interesting to me. I mean, it's another problem to solve. The maker in me is fascinated by how people think, and so yeah, if you've got that mindset, that can be certainly helpful.
All right, I know we're at time. I don't know if you have a hard stop, John.
I got 4 more minutes, and then I gotta jump to something else for.
All right, we'll do one more question. This is a good one. What are incoming competencies for an entry-level FT role?
Yeah, so on the engineering, our engineering team is the largest team that we have. So if we're thinking about on the technology side, we generally hire hardware engineers, people that are coming with an electrical engineering or a computer engineering degree that have demonstrated experience in projects to be able to show off that they're able to build things. I mean, like, that maker mentality is pretty central into a lot of what we think about. We hire software engineers. Usually software engineers are folks that have more experience. I mean, there's a wide range, but usually tend to be folks that have a experience in a few different areas. So they may be comfortable writing Linux kernel drivers, like I mentioned before, or they have some experience there, as well as user space applications. We hire signal processing, folks that have done software signal processing. We hire mechanical engineers, people that have experience designing housings and doing thermal simulations. We hire FPGA engineers, which again would usually be computer engineering or perhaps electrical engineering coming in. So that kind of runs the gamut. But yeah, we've got 2 new folks that just graduated that started in our team literally this week. We have 2 fresh outs that are starting this summer. So we're always interested in folks that are kind of fit the bill and have the right makeup. If there's interest, by all means, shoot me an email, and we can kind of take a peek at things.
All right. Well, thank you so much, John. This was a great talk. Thank you, everybody, for joining. If you have any more questions, you can always reach out to us at contact@aifutures.us. And you can also reach us there at aifutures.us. That's our website, so you can find all of the information about the program, any upcoming talks that we have, or any other, places we're going to be. So yeah, thank you so much for joining, and thank you again, John. It was great.
Awesome. Happy to help out. Have a good day, Molly. Have a good day, everybody. Bye.
Great. Bye, everyone.